We are going to discuss the if statement and switch statement. Both statements are conditional statements. Conditional statements and loop statements are flow control statements. A flow control statement is a statement that directs a program's execution flow. The flow is determined by a condition or loop. Conditional statements execute a certain statement if the condition returns true or false, while loop statements execute a set of statements over and over depending on the condition. In this video, I will cover the conditional statements. Another name for conditional statement is decision statement. It can be called a decision statement because our program must make a decision when it meets an if statement or switch statement. Let's start with the if statement. Java provides three types of if statements. First is the if-then statement. Second is the if-then-else statement. Third is the if-then-else-if statement. The syntax for if-then begins with if condition. If is a keyword that always starts the if statement. The condition generates a Boolean result which returns true or false. After the condition is an opening curly bracket followed by a statement. This statement can be a block of statements that's only executed if the condition is true. A semicolon completes the statement. The second bracket is a closing bracket and only required if there is an opening bracket. Next is the syntax for if then else, which contains an if condition, statement, and brackets, just like the previous statement. However, this statement includes an else clause. After the else clause is a statement that can be executed. We see an if keyword, condition, opening bracket, statement, semicolon, and closing bracket. The same information that was already covered for if-then statement, except the second statement. Now we get a better picture of the statements. If the condition returns true, then the first statement is executed. But if the condition returns false, then the second statement is executed. The else clause extends the if statement when the condition returns false. The last if statement is if then else if. It looks like the previous statement, but there are some clauses before the else clause. We have a clause for else if followed by a condition. There's also a statement. Depending on our program, we may add more else if clauses with a condition and statement. We have an if statement, condition, opening bracket, statements, semicolon, and closing bracket. An else if statement extends the if statement. There are three descriptions that explains statement. The first statement executes if the first condition returns true. The second and the third statement execute if one of the else if conditions returns true. All of the conditions are evaluated using a top-down approach. For example, a top-down approach using this syntax evaluates the if condition. When the if condition returns a false result, then the program flow evaluates the first else if condition. After the first else if condition is evaluated, the program flow evaluates the second else if condition. The same top down approach would continue if there were more else if conditions that returned a false result. Soon as a true condition is found, the statement associated with that true condition is executed, and the remaining conditions are not evaluated. If there are no true conditions, then the else statement is automatically executed. The else clause extends the if statement by operating like a default condition when all of the other conditions are evaluated and returned a false result. Now let's demo the if statement. Let's provide a test. Since the if statement is used to make a decision, we build our test by assigning a value to a variable such as int age equal 34. Start by writing if. We have the option of writing our if statement from scratch or use IntelliSense. You can click Control Space to bring up IntelliSense. We see an if and if else statement. I am going to select if, and you see the syntax is already designed for us. The condition will be our test where our program flow must make a decision. For our condition, let's go ahead and write if age equal 24. Remember from the 9th video, Java variables and operators? One equal symbol assigns a value like int age equal 34, but two equal symbols perform our test to verify if age equals a certain value like 24. In this test, age is not equal to 24. Next, we have our statement, which is also called a body. Sys out. What do we want our program to do? If age equals 24, then print age equal 24. Let's run. We do not see an output printed to the console because the condition was not true. The statement for if condition only executes if the condition returns true. This statement returns false. Let's copy and paste. Then change 24 to 34. Let's run again. Now we see an output because age is 34. However, writing two if conditions is not efficient for our program. Let's implement an if then else statement, which is more efficient. Copy and paste the code, then replace if age equals 34 with an else clause. Run. We get the same result. Age is 34. I prefer to use an opening and closing bracket, although they are optional. Personally, I believe the brackets make our conditional statements look more organized. Let's remove the brackets and run again. Age is 34. This is how an if-then-else statement works. We write if and a condition to test our variable. If age equals 24, then print age equals 24. But if it does not equal 24, then print age equals 34. There is a downside to the if-then-else statement. It is more efficient than the previous statement, if-then. But the downside is the program flow only have two options, if condition and else statement. Next is the if-then-else statement, which gives our program many conditions. Let's use age as our variable again and write some conditions. If age is greater than or equal to 65, then print you are eligible to retire at age, which will be 65. Else, if age is greater than or equal to 20, you are not eligible to retire at age. Copy, paste. Else, if age is greater than or equal to 13 and age is less than equal to 19, print you are a teenager. Else, sys out, you are not old enough to work at age. If you have not watched the Java variables and operators video, check it out, where I explain operators greater than or equal to, the and operator, less than or equal to, and the concatenation operator. Let's run. You are eligible to retire at 65. Change 65 to 40. Run. You are not eligible to retire at 40. Change 40 to 16. Run. You are a teenager, 16. The if condition is the main test and will execute its statement if the condition returns true. The else statements are additional conditions just in case the main test returns false. Else has a default statement just in case all of the conditions return false. Let's change 16 to 1. Add a breakpoint, then debug. F5 to step into our program. age equals 1. Do you see how our first condition is highlighted and getting ready to be evaluated? When I step into our program again, the first statement will get skipped and the next condition will get evaluated. F5. Else if age is greater than 20. F5 again, the next condition, else if age is greater than 13 and age is less than 19. F5 for the last time. We'll finally execute the default statement. You are not old enough to work at 1. F5. That's one of the downsides to the if then else if statement. All conditions are evaluated until a match is found. When a match is found, then the program exits the flow. However, if a condition is not found, then the default statement is executed. That's it for all three if statements. If then else, and if then else if. Next is the switch statement, which does not evaluate all the cases like the if statement evaluates all conditions. The syntax for a switch statement begins with keyword switch and a variable name. After the required opening bracket, there is a case value followed by a statement or block of statements, then the break keyword. Keywords are also called reserved words. A switch statement has multiple case values, multiple statements, and multiple break keywords. The blue dots indicate there can be many more case values. After the case values, the switch statement has an optional default statement. For a lot of situations, the switch statement is more efficient than the if statement. Starting from the top, we see a variable name equals a value. For switch statements, Java does not allow the value to be a double or Boolean primitive data type. The value must be an enumeration, string, or primitive types, byte, short, char, and int. Switch checks the variable's value. All we add is the variable's name within the parentheses. After the variable's name, we have the opening bracket followed by the case values. The case values verify if there is a possible match for the value. If there is a match, then our program executes the associated statement. The semicolon completes the statement or block of statements. Next is the break keyword. The break keyword is optional, but I have never seen a switch statement without a break keyword. All of the statements at and after the matching case value executes if break is not available. For example, if case value 1 has a match and there are no break keywords, then case value 1, case value 2, case value 3, and the default statement will all execute. Therefore, the break keyword exits out of the program flow. Default is another optional keyword that should always be included in our switch statement. The statement for default executes if there is no case value match. Then we have the closing bracket. Now, let's dive into our demo of switch statements. Let's imagine we have a track race. The contestants receive a medal if they come in first, second, or third. For our switch statement, we initialize the variable with the value int medal equals 3. Next, we write switch. Just like the if statement, we can choose to write our switch statement from scratch or use IntelliSense. I'm going to use IntelliSense by clicking Control space, then select switch. We change key to medal. So far, we have switch and our variable, which is medal. The purpose of switch is to test our variable by finding the value. Right now, we have hard-coded our value to be 3. However, our application would send a variety of values. So let's write those other values. Case 1. This means if the value of medal equals 1, then it will execute sysout 1 equal gold medal. Break would exit out of the program flow after printing 1 equals gold medal. We can add a case for as many options as we want. To save time, let's copy and paste, then change case 1 to 2. 2 equal silver medal. Copy and paste again. Then change case 2 to 3. 3 equals bronze medal. The last thing we have is default, which catches invalid choices. If medal does not equal 1, 2, or 3, then our program flow execute sysout no medal. We don't need a case and a value for default because the program knows if the other values are false, then execute the default statement. Let's run. Three equals bronze medal. Change 3 to 2. Do you remember what happened with the if statements? Each condition was evaluated until a match was found. Look what happens with the switch statement. Place a breakpoint at switch medal and debug. We see medal has a value of 2, then step into. And our program flow goes directly to the statement for case 2. It bypassed case 1. Switch does not evaluate every case. Step into again, and here's the output. 2 equals silver medal. Now we are at break, which will exit the flow after execution. F5. Break is optional. But let me show you what happens when we remove all breaks. Change 2 to 1. Let's debug. Medal has a value of 1. F5, and execution goes directly to the statement for case 1. F5 again, and 1 equals gold medal. However, there is no break for case 1. So execution goes to the next statement for case 2. So execution goes to the next statement for case 2. The same process continues until we execute the default statement. F5, and we see 2 equals silver metal. F5, and we see 3 equals bronze metal. F5, and no metal prints to the console. Let me add the breaks back. Break, 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 and break. That's it for the switch statement. I mentioned the switch statement is more efficient than the if statement. That's true, but we should implement an if statement and not the switch statement for 2 situations. The first situation is when our test involves more than one value. Notice how our demo if then else branch tests for 3 values. Age is greater than or equal to 65. Age is greater than or equal to 20. Age is between 13 and 19. We cannot test for more than one value using a switch statement. For switch, we test for one value, metal equals 1. As a result, we should use the if statement when we have more than one value to test. The second situation is when we test for Boolean conditions or floating point values such as type double. Switch does not allow doubles. I would write double cost equals 98.76. Then change metal to cost. Notice the error states cannot switch on a value of type double. The same happens for Boolean. Boolean result equals false. Change cost to result. The error states cannot switch on a value of type Boolean. Only convertible int values, strings, or enum variables are permitted. Change result back to metal. Then comment double and Boolean. Cannot use type double. Cannot use type Boolean. You can download the presentation and the code at tinyurl.com Java-conditional statements. TYNY-URL.com/JAVA-conditionals.
All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium Automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.